We have the main menu of GEOFORM1. We're just going to go through the walkthrough. So we have, as you can see, the angle formulas, arcs and chords, perimeter and circumference, 2D area, lateral and total surface area, volume, and we have more. I'll show you the more menu real quickly. Linear equations, slope formula, circle in the coordinate plane, and basic trig. So what we're going to do is walk through the angle formulas. So a lot of people have trouble with complements versus supplements. Some of measures of interior angles of a triangle is 180. Some of measures of a quadrilateral. And then this sigma, this little Greek symbol looks like an E. It's a sigma. So sum of measures of interior angles of an n-gon is n equals 180 times n minus 2. So just so you know, that sigma is some formula. Okay, so measure of each interior angle of a regular n-gon is 180 times n minus 2, all that divided by n. Sum of measures of exterior angles of an n-gon is 360 degrees. Measures of each exterior angle of a regular n-gon meaning if you have like 7, like n equals 7 sides, it would be 360 divided by 7. So let's go through the arcs and chords. These are a little more complicated. What I'd like to do in the next iteration of this program is show you a visual that can describe arcs versus chords. So the central angle intercepting an arc of A, angle 0 is angle A. So the central angle means it's actually emanating from the center of the circle. So think of like cutting a quarter of a pie. That angle would be 90 degrees and the arc would also be 90 degrees. Now you inscribe an angle intercepting an arc of A, it's going to be half of A. So think of some deranged pizza slicer cutting a slice of pizza all the way from the other side of the pizza. So that'd be half of A. I'll maybe include an image of that right here. Then we have angle A formed by tan, chord intercepting arc of A. A lot of these are a little complicated. I'll try to include visuals of these. Let's just continue. That's probably here. Let's go to 3, perimeter circumference. A little more straightforward. Rectangle, perimeter is 2 times the base plus 2 times height, or 2L plus 2W. Square, perimeter is 4 times S, S meaning side. Circle is pi D, or 2 pi R. A little more straightforward there. And then we have 2D area, which is wonderful. So we have it for rectangle, parallelogram, square, triangle. Just so you know, B is base as a length, and then H is height. B meaning base, the lowercase b is the length of a base. So sometimes there's a big B, and that usually means area of a base. So rhombus and kite, area is 1/2 diagonal 1 times diagonal 2. Circle area is pi r squared, classic. And then regular polygon, A is 1/2 apothem times perimeter. And equilateral triangle, it shows up so often, I just wanted to put that there. S squared red, 3/4. S is the length of a side of an equilateral triangle. And we go on, lateral and total surface area. So I just put L instead of like LSA, lateral surface area, and T versus TSA, total surface area. So we have P, the perimeter of the base times the height. And then we have the total is perimeter of the base times H plus 2B, B meaning the area of the base. Cube, lateral area is 4S squared, and the total surface area is 6S squared. Cylinder, we got 2 pi RH for lateral, and then total is 2 pi RH plus the 2 pi r squared, the tops and bottoms of the cylinder. Regular pyramid, we got 1/2 PL. This is the, the L is the slant height, and the P is the perimeter of the base again. And then B right here for the total surface area, that's going to be the area of the base. Cone is a very similar thing, pi RL, pi times radius times L, meaning the slant height. I'll do a little image right there, okay? And then sphere, total area is 4 pi r squared. And then we move on to volume. So you see this, I don't want to go through it. You can obviously read it. It's pretty straightforward. The sphere is a cool one, 4/3 pi r cubed. And then we go on to the more menu. Linear equations, just even though you may not have this in all of your geometry classes, sometimes they do ask this. So it's just good to know the slope-intercept form is y equals mx plus b, where m is slope and b is y-intercept. Standard form is ax plus by equals c. And we have the point slope form, y minus y1 equals m times x minus x1. Again, m is slope, and then the x1, y1 is the coordinate of that one point you're given. And a horizontal line would be y equals b. An example of that would be like y equals 6. So that would be a horizontal line at y equals 6, and then vertical line, x equals a. That would be something like, say, x equals -3 would be a vertical line where a is 3. And then we continue again on the more menu. We have the slope formula. Now look, this delta y over delta x, don't let it get into your head too much. It just means change in y over change in x. And the algebraic way of showing that is y2 minus y1 over x2 minus x1. Again, x1, y1 would be the coordinate of your first point, x2 comma y2 coordinate of your second point. And it is change in y over change in x. And then just as long as x1 doesn't equal x2, because you'd be dividing by 0, which is a big no-no at this level in math. And then we go to the more menu again, and then we have circle and coordinate plane. Because every now and then they do ask this in a geometry class. Not everyone, so this may be superfluous to your needs. Or extraneous, I don't know, probably superfluous would be a better word. But we have x minus h quantity squared plus y minus k quantity squared equals r squared, where h and k is your center and r is your radius. And then we go on to the more menu. And the last thing we have is some basic trig, or sine theta, cosine theta, tan theta. We use thetas usually for angles at the level of geometry and above. Some people can still use variables like x, y, and z, but usually theta. And then it's the opposite of hypotenuse. So some of you guys might have been taught SOHCAHTOA. So is S-O-H, sine is opposite of hypotenuse. Cosine is adjacent for hypotenuse. And TOA, tan is opposite over adjacent. So we're just using the first letters there. And then also this is the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Put it in the comments if you'd like me to include all of the Pythagorean identities. I can put the other two there just pretty easily. Law of sines is sine A over A equals sine B over B equals sine C over C. Always try to use law of sines over law of cosines. It's just that there's a lot more going on in law of cosines, which means a lot more chance to make a mistake. It's just kind of this engineering thing. You want fewer moving parts, and just like in math, you want fewer variables if possible. So we got the law of cosines for you, and it's 3 different iterations depending on what you're given. So look, if this helps you, hit a like, and then you go to mcstutoring.com and buy this program, GEOFORM1. And then again, in the comments, if there's any other features you'd like to see, put it in there. This is how we've changed that SAT program, and then also another program to suit the needs of the users. You guys are the end users of this product, so comment. Oh, and then tell us what you need. Like, hey, I don't need this. I need formulas for stats class or something like that. Put that in too. The next program we're going to make actually is a stats program, which should be due by late May 2024. And again, probably over the summer, we're going to remake the SAT3 to make it SAT4, so it answers almost 50% of the questions for the College Board practice SATs. Okay, good luck in all your math endeavors, and I will see you next time.